All right, part two of this lecture deals with electric potential energy. So we've talked about potential energy before. Remember that potential energy is your stored energy. So what we're talking about with electrical potential energy is your stored energy a charged particle is going to have. So it's going to have that potential energy when it changes position, just like we had when we looked at gravitational potential energy and spring potential energy. As you change your height, your gravitational potential energy change. As you change your position, you're going to change your electric potential energy. Okay, and again, you're looking at these as it's a charged particles moving in an electric field. So just like with gravitational potential energy, your potential energy and your kinetic energy are opposites. Remember that idea of conservation of energy. Your total energy cannot change. So if your distance is getting more, your potential energy is increasing, then that means your kinetic energy is decreasing, so your object is slowing down. And then you have the same thing on the other side. If your potential energy is decreasing, that means your kinetic energy is increasing. So as an object gets closer and closer to the source or to the bottom, that means that it's speeding up. So that electric field's going to pull you along. And so as you get closer to the plate, to the object that's producing that electric field, your position's getting smaller and smaller, so you're speeding up. And your electric potential energy, or EPE, is measured in joules, just like work and all of the other energies that we looked at before. Okay, what we're talking about for some of our examples for electric potential energy is what happens when we have a uniform electric field. Okay, so what that means when it's a uniform electric field is that your direction and magnitude are the same throughout the entire piece. So what you end up with, sorry, my picture's going to be really bad, is you have a plate on one side, you have a plate on the other side, they're actually parallel, and then one of the plates is going to have a positive charge, one of the plates is going to have the same charge, but it's going to be negative. Okay, so since it's a uniform electric field, and that means it's going to have the same direction and magnitude on any point. So that means if I'm comparing one positive, one negative, remember your electric field always goes from the positive towards the negative. And so the electric field at all of these points, all these little arrows I'm drawing, are going to be the exact same. So it doesn't matter if you pick a positive particle that's towards the top, negative particle that's towards the bottom, because your electric field is going to be the exact same. So what you end up with are two parallel plates, one positive, one negative. Whatever the charge on this one is, the charge on the negative one is going to be the exact same. Okay, to calculate your potential energy, we're generally going to be looking at the negative sign with the lost. So we're looking at that it's losing potential energy, so it's increasing at speed. So your equation becomes EPE equals negative QED, where Q represents the charge, just like before. This is still measured in coulombs. Your electric field is going to be looking at the electric field that's produced between those two parallel plates, still measured in newtons per coulomb. And then D is going to be your distance, how far that charged particle is moving, measured in meters. Sorry, I was going to put D again. So measured in meters. And then your potential energy is again measured in joules. Okay, so you just have to rearrange that equation to solve it for whichever variable it's asking for. Okay, make sure you include the negative sign on the charge. So if your particle is an electron, then this Q will be negative. If it's a proton, then Q is positive. So just pay attention to the sign on the charge as you're going through the problem. And then if the problem ever asks you for just magnitude, remember that magnitude is a positive value. So you don't even have to worry about the negative side.